Hello. Hello. I hope you're all doing great. Let me just share this. I was watching a bit of Tim Kaine just before I started. I think we're live. We are on OBS today, so feel free to let me know if the audio is very bad or whatever. I hope we're live anyway. Let's just wait for the chat to come up on my other screen. There we go. There it is. Fantastic. All right. I've made my lunch. Let me just grab the rest of the chat. Let's get off OBS. Now I do have alerts enabled, but I hope I really hope that they are still, doing things. As far as I'm aware, that red box means that there'll be a thing on here when people, or if people donate. But for now, it is TT. Yeah, I'm very aware. The yes, the bun rewrite is crazy. Although I'm with not to turn this into a holy war straight off the bat. What's his bloody name? I can't remember. James Kelly, I think. I'm with him, to be honest. Sometimes people write bad code, and and then say, well, your programming language is the problem, which it isn't always the case. Okay, so I took a day off yesterday, and I kind of regret it, to be honest. I feel extremely sluggish today, and I'm so not motivated at all. I don't want to code. Despite having a day off. The reason I decided to take a day off was because on Tuesday I was becoming a big crank. Andrew Kelly, that's the one. Thank you. About I was getting stressed about nothing that was worth getting stressed over, and I was getting a bit snappy with people, and it was getting silly, right? So I was like, I'll take a day off, but I think I should have just taken it easy rather than taking a full day off. I literally did 10 minutes of work yesterday. And now because of that, I'm feeling absolutely demotivated. I don't think it's always a good idea to take a full day off if you can avoid it. So the O just posted a 1 hour video crashing out over Andrew Kelly's blog. Yeah, it's I feel like The way it seemed to me, I watched the Fireship video, so I watched for 5 minutes video on it. Apparently internally, this is what Andrew Kelly would show, like how to not write Zig code. So there's that, and I think that's a big indicator that the way that we're handling memory was subpar, and that caused a load of issues. So we are hello, Angelica is a cutie. So what did we end up achieving last time? So we achieved a couple of things. We can reduce the size of particles, we can change the color of particles, we can have different textures for particles, and we now have a crude age system for particles. So if I was to run this again, and we shall see, hopefully, a blue explosion just above our head, assuming that I haven't broken anything, and the particles disappear. Now, this isn't ideal because I'm just adding a number, and eventually, the particles disappear, but there's no real way to reset them as of yet. I can't say, oh, they are 0, and what I want to try and do today is basically move the particles into a place that makes sense based on collision detection. So so I'm going to try and do that. I'm also going to try and fight my procrastination urges today, because I'm super, I don't know what it is. I don't know if you guys can relate, but I get super bored, and then I convince myself that because I'm bored I shouldn't work because it's boring, and then I just get even more bored, and then the cycle never ends. So I'm going to try and beat myself up today and actually get something done. without completely losing my mind and stressing over the fact there's like 20,000 different things I need to do. Because that's why I was getting stressed. I was thinking about like too many things to do, and that isn't based at all. So yeah, we should. Okay, so here's the age thing, right? But I want to, before I do that, I have a particle set. Are we? Yeah, we're in debug. So we have a particle set that has a transform basically, and I need to basically update this transform, trigger a draw of these particles from scratch. So I need a way to like basically tell the shader, oh, in the compute shader anyway. We want to redo the shaders again. Sorry, we want to redo the particles. We set the position, the new particle position, based on a collision detection of that particle set, and then we also need to reset the age of the individual particles. So we need like a clear function really. I'm not entirely sure how to do that though. So it might be the case where we just kind of do a VK fill buffer with zeros or something. I'm not entirely sure if that's a good idea, depending, because it's an enum. So what do we have in here, right? We have these comments are just kind of like commented out other particle effects that we could use. So I'm just kind of leaving them around for a minute. We have a crude random number generator, which I'm going to leave for now because it's good enough. It's not perfect at all. Yeah. Hi, EBB. How are you doing, dude? Thank you for joining us. Yeah, I hope you're all having a great day, by the way, guys. Yeah, so we want to effectively set this to 0 on a particular condition. The downside is this is all CPU based, and I don't want to have a situation where we tie the compute shader to the CPU. The problem with doing that is the CPU, this is a GPU driven rendered whole process of things, right? It's the reason that we can render 1 million particles. Not very well, but we can render them. It's because it's all on the CPU. There's no like sorry, it's all on GPU. There's no CPU getting in the way. So we've got to be very careful here that we don't have a constant uniform or something that's being pushed on the CPU, because that kind of makes it kind of CPU bound again. Because we'll be waiting for like a buffer to transfer, go over PCIe. Even if it's got rebar, whatever. We're still having to do like a big memory fetch, and the whole point of this is to try and set up a system where we can be like, all right, fire and forget. Particles are on the GPU going from buffer to buffer to buffer, doing things like that. So we've got to be a little bit careful with how we design this and make it in a way that makes sense. But that's what I'm going to try and do. But I don't quite know how yet. So yes, that is the goal. We do have a we are more tied to the CPU on this side, which is nice. So we maybe can set some things up that we can make this readable as well instead of just write. Sorry, writable. Maybe can write to the buffer, but I don't know yet. Yeah. So this is the idea, right? We want to have this new particle set have a new thing. I think that's going to be not that difficult, but setting the age is going to be harder, I think. Resetting the age is going to be the tricky part. So if we look at this again, because this is purely a this is purely dealt with in the shader itself. I don't see yet a way around this. We might have to kind of clumsily kind of have a reset of this of all the buffers, because this gets updated at the beginning of the frame. Sorry, where is it? This gets updated at the beginning of the frame, but we can. There's probably a way to clear this buffer, and that's what we need to do, right? We need to set this buffer up in a sense that it's completely clear. Hello, Emmanuel. How you doing, dude? And yeah, that's what we're going to be doing today. We're going to be trying to clear this buffer out, and we're going to be setting the position differently. So I'm going to tackle the clearing of the buffer, I think. But we just got to trigger it from the CPU side. Otherwise, I don't think there's any way of doing it otherwise. Now, the trick is to figure out how to do that. So let's just look at my code a bit. Yeah, I hope you're having a great day, Emmanuel. For those who are not keeping up, England lost the match against Argentina in the World Cup. So I'm supposed to be devastated. As someone who's not really into football, this is it's a bit lost on me, I have to admit. But I thought I'd just bring it up, regardless. Football did not come home today. Hello, hello. Who cares about the World Cup, bruh? Well, a lot of people. I'm not going to bash football, but it is what it is. Was rooting for England. Never mind. Semi-finals is fine. I know, quarterfinals. Quarterfinals is fine even. We'll be fighting for third and fourth. We'll be fighting for third place anyway, so it is what it is. Can't win them all. Yeah, I don't like sports that much. I don't like sports that much either. I tried to get into Rocket League sports for a bit, and even then, I was like half in, half out. You know, it was nice keeping up with the players, but I didn't care at all about the teams. I just couldn't. I couldn't bring myself to care at all. But anyway, I love sports. Yeah, it's definitely it's good that you like sports. I think it's like a good. I think it's a good communal thing. We can get together and like root for your favorite team and stuff. Hey, Ratchet, how you doing, dude? So you know, I can't be that type of dweeb who puts people down for liking sports, because I think it's generally a good thing for most people. Right, okay, so right, how do I want to clear this buffer out? That's the first question. Oh my goodness, that is miserable. I'm sorry to hear that, Emmanuel. I wish you a speedy recovery. I've got like a back injury, so it's, oh my goodness, it's it sucks when you get injured like that. Sounds like a rough game as well. Jeez. I'm sure you'll bounce back even stronger. Not just rooting for professionals, yeah, playing for fun, exactly, yeah, you know, it's nice to have like a thing that people get together and do outside of the internet. Pulling a Vulkan by naming my new vertex buffer class to vertex buffer 2. That's fun. 33. Alright, let's think about this. What do we want to try to do here? How are you, by the way? General, I'll call you that. Hopefully that's chill. Yeah, I'm 67. The memeiest age of all time. Right. How do I want to do this? So let me just think about this for a bit. This is going to be a bit of a kind of an exploration of like what should be done. So we need to reset a buffer, and it's cool that we can. I want to do this on a particular event. So we're probably going to have a memory barrier. But where's my oh, I've moved everything into particle renderer. Yeah. Well, make sure you understand you're joking with that. Right, okay, so what I want to do is remember, Ratchet does mog a lot of people when it comes to graphics programming, so watch out. Okay, so we have a VK fill buffer, and we kind of just fill this with 0. So I might want to investigate this and see if we can do this outside of a, because it would be nice to kind of fill the buffer with nothing. And Jellic is a cutie. I'm sure Jellic is a cutie is joking. Or attempting to joke anyway. Alright, so we have this, and I want to see if we can fill this up with something other than just numbers. So, okay, so fill a region of a buffer with a fixed value. Now, the fixed value is there a way to fill a buffer with just like reset the buffer, right? Like bring everything back to 0. Like a mem set, but for not just a set value. Do you need to 0 the buffer here? My goal, just so, yeah, let me show you Ratchet and see if you can see what I'm trying to achieve here and point me in the right direction, perhaps. So you see this explosion that we have? Like, I age all the particles out and they disappear. I then want, obviously, to then do it again based on a CPU event, right? So how this is working in the... I'm trying to avoid... yeah, let me just explain. How this is working, so just the age, the velocities, we also need to 0 the velocity, but the age would be fine if I could just get that working for now, because I can always just reset the position. I know I need to do the same for the age, actually, completely. Alright, okay, so these two values, basically, I need to reset them after a CPU thing has happened, like maybe a collision detection or something. And what's happening at the moment is the age is getting, like, you know, randomly added value here. And the velocity, the position is getting a velocity over time, right? So what I need to do is basically reset this so it doesn't keep increasing each frame after a particular event. So what I'm trying to do is effectively be like, okay, reset the values with and the reason that you may think, why don't you just send in maybe a Boolean or something. Maybe another buffer, I don't know, something like that you can just update. I'm trying to do this in a way that's GPU based. It might not be possible, so we'll find out with a bit of research. So what I'm trying to do is effectively keep everything on the GPU as much as I can, because this is all GPU driven. I kind of don't want to bring this have the GPU have to wait for the CPU to do something, with some like waiting thing. So what I'm trying to do at the moment is basically find a GPU command that effectively resets our buffer. The problem with our buffer at the moment, though, is it's in particle data. So I'll just grab out. It's not values, right? It's a couple of things, and I want to be like, okay, reset everything. Now, it would be nice to set them to particular values. That would be even better, because then I can set the particle set, which I'll maybe have to extract out anyway, because this is a hack, really. I'll come back to why if you're interested. But generally speaking, I'm really interested in resetting this to kind of 0, 0, 0, 0. And yeah, I'm trying to do it through the GPU at the moment, because it would be nice if I could do that. Keep it all GPU based, basically. That's my initial goal. If it's not possible, I will, of course, push up some variables into the shader and just kind of have a condition which resets everything. Yeah, so that's the idea. We could, the other thing we could do is have another shader, but I think this is a bit overkill. That kind of resets everything if we don't have the flexibility via a Vulkan command. I just know you can reset a value, but I don't know if that's possible. So I'm just going to read into this. So feel free to, fill me in with some Vulkan knowledge if you know. If not, I'll investigate. But again, no one should feel obliged to. I'm just saying that if you have something that you know about and you want to share it, feel free. Anyway, so we have the command buffer, the destination to be filled, the offset into each byte at starting, which to start filling must be a multiple of 4. Okay. The size of the buffer to fill. The size must be either 4 or the whole size to fill the range of the offset. And used to remain. I think I'm going to have to make this transferable, actually, now I think about it. Is there a VK reset buffer? Okay, let's have a look. I don't know every command off by heart, so if you found something. Hopefully this isn't a troll. Alright, reset. Okay, so we've got reset event. No. Is reset command buffer. I don't think there is a reset buffer. This is close to what I want, but it looks like it's one value. Now ideally, like I said, I would like to just kind of reset it to a particular value. But I think what I might have to do on, sadly, is let me think. I don't think there's a way around it now I think about it. With GPU-driven rendering, the CPU can only communicate what work needs to happen. And so it does via sending data. On the GPU, you can use this data to generate more work. GPU-driven rendering, the CPU only communicates what work needs to happen. Okay. Yeah, I think I was probably being forced into this anyway. So we effectively need a way to reset this buffer. Also remember that you can use a compute shader to write anything to any buffer. Yeah, I was thinking that too. I think I'm going to... let me think. So if a compute shader can write anything to any buffer, which is can chill beans, maybe there's a way to set up a reset. The solution sometimes is just do another dispatch. Yeah, I was thinking that. Yeah, we need like a reset buffer. Because there was, I think I did mention that, didn't I? Another compute shader just resets everything every now and again. With the correct barriers in place, that would be relatively quick. Although it would be a bit it would bloat the code up. But I think in general that's probably an efficient way of doing things. In the graphics/compute queue, yes. I'm just using one compute queue, one queue at the moment. Right, so let me think about this. I'm in a bit less of a rush today, if that makes sense. I feel less, just because I took a day off yesterday. I feel definitely more chill. I feel like, yes, for the past for the past week or even like 2 weeks, I feel like I've been becoming a bit manic with my decisions. A little bit, anyway. A bit impulsive, perhaps, that would probably be correct. You missed the second last message. Oh, yes, I did actually. VK fill is internally a compute dispatch. Ah, okay, interesting. In many drivers, there we go. Okay, that's actually kind of good to know. All right, let me think about this then. That's actually that's actually quite good to know. Let me think. If I want to do it on the GPU, I definitely could reset everything with another compute shader. So we've got two options effectively. For those who don't know what we're talking about, this is a compute shader. A compute shader is just a generic shader that can do anything. Well, it can do anything. It's general purpose compute. So, you know, it can be used to do whatever. It can't do stuff like other shaders can do, like you know, in theory, right? It can't fill up fragments for a fragment, you know, in the fragment shader, for example. It's not really designed for that, but it's general for general compute, meaning that yes, we can easily set up a compute shader to do some generic operation on a buffer. That's completely chill. That's why we can get around that. We can explain render doc and compute shaders every stream. In compute world, a dispatch is equivalent to a draw call. Indeed. So yes, that's exactly right, Ratchet. So now we need to figure out exactly what I want to do and how I want to do it. Yeah, I just want to make sure people are caught up. And I'm also thinking about people who are watching this in the future. And it also helps me think when I explain stuff. So there is a couple of reasons why I do yap about the same thing. Even if you've heard it before. And it also allows you guys to challenge my assumptions. Maybe I explain something slightly incorrect and maybe you can jump in. And be like, no, escape point, you completely made a mistake there. That's not how anything works at all. So yeah, there's a couple of like positives to like re-explaining things. Right. That is the motivation anyway. Using the fill commands, can't you just fill the size of the buffer and struct? It sets all the values to 0 in, yes. Yeah, you can only do that, multiples of 4 bytes, which is fine because we do that. We do have a very specific, for some reason, I don't understand why. When I try to access my buffers via a buffer device address, I have to align them regardless if I've got the scalar thing here. So they are 4 byte aligned, but even saying that with the fill buffer command, that only resets everything to 0, which would be perfect for the position and the age, but it's not perfect for the set, right? I have a particle set here that's just arbitrarily set to some value, but we need a way to basically, for each particle in the dispatch, we need to set its particle setup, meaning that, yes, we can do this in the compute shader, but we also need to be like maybe, because maybe the particle set is like 4, right? And this is all zeros, meaning that eventually we would run into the problem where VK fill buffer would be inefficient anyway. If it's not a multiple of 4, the rules are weird. Go read the spec if you want. I see. Still very new to this. Eventually you will. I like that. I feel like it's a threat at the same time of, yeah, you eventually do end up having to read some of the spec. It's unfortunate, but it's part of the process. Yeah, I like that. Eventually you'll have to read the spec. Urgh. That's kind of funny. Anyway, let's think about this for a bit. So the threat is to Emmanuel's sanity, indeed. All right. So let's think about this. Do we want to do a compute shader, or is there a way to send in data to the compute shader in a way that's not... let me think. How do I want to do this? The particle set is kind of lame at the moment because it's emulating something that should be done. Okay, so there's this idea, right? Let me I might not have to worry about the particle set. Hear me out. Let me talk through this and see what you guys think. So at the moment we have this idea of a particle set, which is like really insightful, I think. But the way that it's done in the GPU Zen 3 megaparticle system is it has a second buffer which stores for each particle basically a bit mask, which is kind of complicated. You can see it down here. And this bit mask is 1-to-1 for each particle. Ignore the Java. It wouldn't do syntax highlighting without it. So there's this like really complicated like bit masking system where things are chosen based on that. And I think, as far as I'm aware, we have another buffer as well for inactive and active things. So we have like 3 different buffers here. And this, I think, is to reduce at all costs the data that exists within the data that exists within the particle itself. It's basically a compression idea. That's all it's for. It's like a compression optimization. I don't think it does anything like particularly fancy or like optimal, apart from the fact that there's with less memory being used per particle. Hence, it's UVec2. The more particles you can shove in a buffer, right? Now I have like kind of like the standard like a float, like 4 floats and a 32-bit number to kind of emulate this relationship between this bit mask buffer and I think anyway. Let me just read this again. We make sure that our bit field buffer and particles are 1-to-1. Okay, so that corresponds. How do we know which bit mask it is actually? Oh, sorry, which particle set? Yep, so that shares this. Let me just make sure I'm correct here, because I could be completely wrong. All particles are stored in the same buffer and have the same 32-bit field. Yeah, because we don't have the... yeah, it keeps track of the particles. What particle set it belongs to. Okay, yes, yeah, so it is what particle set it belongs to as well. So effectively the bit field buffer is keeping track of what particle set it is. So we have multiple buffers to basically reduce the overhead of the particles themselves. Instead of having 1 buffer or 2 buffers in our case, we would have 4 in our in our case. Yeah, having an alive and dead buffer sounds pretty generic DoD for me. Let me think about my DoD knowledge. You're probably right. I'm just trying to relate it to DoD. So that's why I'm thinking for a minute, based on what you just said. So yeah, for both particle buffers and bit field buffers are divided into 3 main sections. Section 1 contains light, shadows, and everything else. We divide these into sections visible and inactive. We have an additional buffer that stores the bounds of each section in small read-write buffers, computed when the preparation shaders. Okay, so we have preparation shaders. I see. So we have 3. Yeah. So you have 3 buffers: bit field boundary / activation, active, and particle buffers S. All tracking states. Okay. Right, yes. That is true, yes. So instead of a Boolean is alive field, that's exactly... Yes, that makes sense. Thank you for relating it to DoD. You're completely correct there. So yes, we have an array. So I've kind of implicitly done this based on age and initial age, right? So the initial age is the lifetime of the particle. The W component, which I've been inspired by, of the position is we don't have any acceleration yet, so initial age, and then I just kind of say it's inactive when the age is greater than, when the W component of position in our case is greater than the initial age. But I think you're right here. The whole point of this is a data-oriented design optimization where we avoid having this. I think this would be the equivalent, right? This would be a non-data oriented design approach. Is alive, right? So instead of having that on the particle side, we kind of like have we do this out of bound thing, and that's very DoD. Yeah, that's DoD as heck. Right. So yeah, thank you for bearing with me while I figure out. I thought that was a U for a minute, and I was like, what the hell am I written? Right, let me think. Okay, so I'm glad. I'm actually kind of glad I took some time off, because I'm definitely thinking more about what I should do. So yeah. So it has the boundaries. What would this buffer look like? So as far as I'm aware, let's look at this again. So this boundary buffer or whatever So for us, we're just going to have standard, meaning that we would just have an active and inactive section. But I don't understand what that would be and how that would work, to be honest. It feels like we basically have an array that kind of fills up. Goes from active, like completely active, it fills up to the inactive as the time extends. I think for now we can probably avoid this just based on our implicit understanding, assuming that we don't need to worry about is alive yet. If is alive does come about, I guess we would have to do something like this. So yeah, this is I'm gonna write an extra note based on what you've just said there, Ratchet, as well. This boundary buffer is a very DoD thing. It avoids having a bool is alive in the particle itself. Right, okay. Particle struct, I guess. Nah, particle itself makes sense. Alright, so let's think. So we need to send something into the shader. But yeah, I think this runs every single frame. Because it's doing basically, it's generating draw calls which need to be drawn every frame. And as far as I'm aware, do we have particles set in here? No. Yeah, we basically need to be in a position where we don't run this, I think. Alive. It's almost. I'm almost reminded. Actually, I'm reminded of the Portal 1 credit song. I would sing it, but I can't remember the beginning. Or maybe that's a blessing in disguise, right? Anyway. Right, let me think. Okay, so I don't really need these. It would be nice if we just didn't do this dispatch if there's no particles on the screen. And even draw. I don't know if that's worth doing. So, for example, if we have a... Can you read something on the CPU from a buffer? Kind of like a... No particles... No, I think this is just not worth it. Maybe it is. Hang on. Yeah, because if my dispatch is like 1,000,000, like it's going to slow us down, right? Like if I go into here and I have 1,000,000 draw, if I'm drawing 1,000,000 particles, like, and I have 1,000,000 dispatched things, and I have other, and eventually this game gets a bit more complicated and there's other things going on. Then this is probably going to get expensive, assuming that there's no particles left. And it's also true that we need to basically send in the set number anyway. How do we track this? Okay. Dead indeed, Angelica is a cutie. Let me think. Okay, so if you look at the compute shader again, what I'm concerned about now is this hard-coded value. Now, velocity being calculated by this is fine. The problem is the particle set being set in here is fine for now, but it's not what we want. We basically need to set this up so each particle effect has its own dispatch. It's ran when it needs to be ran, and it's not ran afterwards. So I think the first thing I should work on perhaps would be a way to disable this dispatch draw call when the age has exceeded all the particles that exist. The problem is we might end up having to draw that boundary buffer and somehow read it on the CPU. So what I'm talking about here is if I have different particle sets for different, let's just assume that we have multiple, I don't know, effects for different particle sets, right? We could just maybe pass in a new variable. So, let me think. Because we need different effects for different particle sets, otherwise this kind of doesn't make sense. So yeah, what I'm saying here is we need a... Okay, so we need two things here. We need like... one... these come hand in hand, so they're basically the same idea. One, we have a particle set that has one idea. Sorry, one particle sets need different effects in our compute shader. So I assume, I don't know if we could do this actually, but I think we can. Like a switch statement, basically we need to switch over something. So if you have particle set 1, then we do something. If you have particle set 2, we do something else, etc. And the second thing is if no more particles are on the screen, aka I don't know if this will actually happen, but they are all inactive. We need to not rerun this compute shader and the draw call. Because if we have no particles in particle set 1, let's just write this down. For example, if particle set 1 is an explosion, we shouldn't write data to a buffer for all the instance. Now I've got a bit of a conundrum. How do I know which part of the buffer I'm writing to? But anyway, I'll come back to that in a minute. I think that's done in the GPU Zen anyway, so I'm not too concerned. Anyway, so we shouldn't write data into a buffer if the explosion has finished, meaning that all the particles in a particle set have exceeded their lifetime. Alright, so that's the idea, right? So if we have an explosion, we need to be not writing data to that. I think it's an optimization, but yeah. So first things first, I think it might be easier to do ping the first one, not the second one. Maybe we can have a variable that gets passed in. And based on that, we go, okay, half the particles do this, half the particles do that, and we have different particle effects for each. And then we can kind of test the second point. Because if we don't have more than one particle set, then it's going to be kind of tricky to figure out if we've made a mistake by overwriting other people's buffer, other people's data. But we also need to make sure that we're not doing anything if there is no particles to render at all, because this can be quite expensive. Anyway, it's possible that the graphics driver knows that we're not doing anything, but I doubt it. Just because we're not rendering doesn't mean the compute shader knows that we're not rendering stuff. So even if the vertex shader is empty and the fragment shader doesn't do anything, the compute shader I think doesn't have any clue, so it's just going to run anyway, which can be quite expensive, assuming that this is like a complicated particle effect, right? We could end up in a bad situation where we're doing some like nice calculus. But even if it's not, we can just assume that we can like be rendering like 400,000. We can be moving 400,000 things around the screen, and that's just going to cause us like ugliness. Surely you can early out if there is nothing in the particle shader. Yeah, that's exactly what I'm trying to do. But I'm trying to do it on the CPU, because maybe we can just build an if statement in that just tells us that, oh yeah, particle set 1 has nothing in it. Or particle set has become completely inactive. So let's look at our particle set. Now, I don't know if this is possible, but what I'm trying to see here is there a way to basically say... no, it just has yeah, but I think Ratchet might be right actually thinking about it. The reason being, he's right actually, because I would need to... I don't know how much graphics overhead this would cause. We need a dispatch, I think, for each type of compute shader. So let's just say that we're on particle set 3. I don't want to be rendering particle set 1 or trying to mess around particle set 1 and 2. The problem is I don't know how that's going to behave in the shader. Sorry, in the buffer. Because the global invocation is going to be off if we have 3 different dispatches versus 1. If you know how to submit, if you know at submit time, then why would you send over the data to the GPU? I can't quite work out how I would know it's submit time, to be honest. I would need to read data from a GPU buffer. But again, that kind of like... if we're reading data from a GPU buffer, then it becomes a CPU buffer, and we kind of lose our advantage. So yeah, let me think. Who would have thought I'd be thinking from the beginning? I think do you need particles with random uncapped time decay? Random uncapped time decay. As far as I'm aware, we could probably just change the position faster for particles and have them all decay at the same time. So in theory, no. I could probably just say that... The problem is, though, it kind of looks a bit lame. For example, if I do that, this is a very easy thing to test straight off rip. But if I get rid of DT, right? I'll get rid of this for a minute. So add DT to this, times by 0 dot... No, let's do 1. I think that's going to be a particle that dies, a particle set that dies pretty quick. That's what happens if I don't if I kill them all at the same time. It kind of just all blips out of existence. I'll do that again. Alright, so the reason that we had the randomness in is to avoid that kind of glaring, obvious, you know, yeah, this is the difference. Yeah, you can imagine this is an explosion. Right, that's like that looks much nicer. There should be a cap on how long it takes to decay, even if there is some particle decay earlier than that. Yeah, maybe we could let me think. Maybe we could have something separate that kind of does this. I'm wondering if this is a CPU buffer. Like, what is the point of this? Like, when is it used? Like, if everything's inactive, like, how do you actually make sure that's relatively useful? I think the idea would be, instead of... No, I was going to say... let me think. So, what I was thinking for a moment was if we change this to 1, and then do a for loop for every single particle in the active. Is it me, or are the stream visuals messed up? What do you mean, Emmanuel? Maybe I'm on OBS today. So it's possible. We do have alerts on, but now what are you seeing on your screen? I actually don't know. As far as I'm aware, this is what should be broadcasting to the internet. But yeah, let me know what it is, and I'll try and fix it if it is an issue. Okay. Yeah, this is a lot of planning. But I think this is progress. We have made progress, despite us not coding anything. I think I know a little bit more what we need to do. So we need like a switch basically that fills up based on it does an effect and it has a different particle effect, particle set. The second thing is we need to figure out exactly we need a method to figure out if everything's inactive or if something is inactive. So this is going to happen per particle. This happens per particle. So effectively, we need to know here, we need to be like, if... Okay, obviously this is not correct, but is alive. Sorry, is dead, I guess. So you go to true. then we need to be like, alright, yeah, don't do anything. I don't care what particle set you're in. Yeah, just stop. Jello Crazy Cutie said it's fine for me. Thank you. So it looks like it might be your end, Emmanuel. Hopefully it does. So we basically need to know is dead. So is age. I think this is quite simple. I think what we could do is basically pass up the. We could. What I'm thinking then is, even though this is a compute shader, we take the particle set buffer and we stick it in the compute shader, and then we basically have another buffer, and assuming that we grab this, we put this here, and we upload this to the compute shader, do a the same old now of course the we obviously have to change this. Oh, not particle data, sorry. Particle set data. So we have particle set data. The compute shader needs to be changed, but what I'm thinking anyway is the is dead is going to be a simple approach of taking the alright, wrong. Let me march down a little bit. I do need a little data from the particle itself. We take the now this still might cause overhead, but I'm not entirely sure if that's an issue, so I think we might need to profile this. If we set it to like 4 million particles or 5 million particles that all get disabled, maybe that's, maybe you'll see like something that's an issue, but until then we don't need to worry. So anyway, particle sets, so we would need the particle set here. So whatever the particle set is in, so let's just say the particle set is not going to come from the particle data itself. That's going to be set here. So this would be so whatever the value is passed in. We have a dot particle set, and here's a value that we don't own yet. So I'm just going to kind of put like a random number in here, or just like a macro. I don't know. Right, and then we can check, then based on that alone we can get the max age, and then we can get the particle age and blah blah yeah, sorry, and age, and then just get the W component here. Alright, no, wrong. But anyway. So if this is... yeah, if this is greater or equal, then we just return early. In fact, if we have the particle set being passed in, we... oh no, we do. We do need data index. But the less amount of work we can do, the better. Now, we could hack this together a little bit and set the global invocation... kind of a bit nuts, but we could do like a kind of like a Y thing, but I don't think that's a good idea. So that's the idea anyway. So we basically have an early return based on the particle set max age, and we need now this to be what, 32 pointers. And as far as I can tell, this is a static variable. Maybe this is overkill. Maybe we need less data in here. Open and close YouTube. No, it's good. Oh, that's good. Glad that worked out. Right, let me think. Are we storing too much data here? Because we don't really need anything else other than the max age. I don't know. I'm sure that's nothing anyway, because this is a very small buffer. Now that means that we would need the... Okay, so if I look at my particle renderer, everything is here, which is nice. But this also now needs to be handled. Yeah, so here we need to have this compute shader kind of right to the compute shader as well, which is... Where is that done in our other shader for our vertex shader? That is... Okay, so that's done every frame, which is probably bad, but as far as I'm aware, where is the thing uploaded? Okay, so here. Okay, so let me just access it via the shader. So it's actually not uploaded. It's just created, which is chill. Alright, so as far as I'm aware, this is fine, but I could be completely tripping. Because what we need to do then, I guess, is this. So we have the particle set data set up, then we duplicate this. Take the particle set buffer. Let me get the buffer device address to it. I'm going to take a shower, BOB. Well, yeah, see you soon. Have a good shower, I guess. We also need to make sure this graphics pipeline, compute pipeline is set up with a correct sized thingamajiggy. TS doesn't feel like a live stream, it feels like a Discord group chat. Is that, I don't know if that's good or bad, hopefully it's good. Nope. Just accepting a friend request. I basically never say no to these, but I don't really know what they do. Maybe you can scam me easier, who knows. Right, okay, so that's on Discord. Where's the error? Error. Warning. What? What's the error? Let's use this, which is completely useless. Oh, is it a shader thing that just didn't print? Yeah, it's got to be a shader issue. So let's build. Yep, okay, so yes, we still have not set the set. Okay, I am tempted to just throw this into the push constants because I can't think of anything. Because it does feel like we need to dispatch this per set anyway, so you know, if we have like X amount of sets, I think that's just going to be the easiest way to get this data up into the shader, to be honest. So that'll be what? Yeah, so I'm just going to throw in a set number into the push constants. Particle set. It's free. It's awesome. It's an extra 4 bytes. We have lots of space in our push constants. Let's say particle. Say the set, I guess. No. Okay. P set. No. I think people are going to say that means pointer. But everything's called particle set already. Or is it? Particle set. I'm just going to go with that. Just see if that exists. Lowercase, uppercase. And that's going to get that out for us. As far as I'm aware, anyway. That should be good. I hope as well that when I do this and I just return early, the vertex shader knows what to do with an empty draw call. We'll see. All right. Particle set, and this would mean that we set the particle set here. So yes, so we're gonna have one particle set again, but with this progression, hopefully we end up with multiple particle sets, which is the idea anyway, all doing different compute shader things based on our dispatch. So yeah. So we're gonna create different draw calls. I've got to be careful here. So this is also doing the draw call count. And does that mean we want different draw calls per particle set? So let's just say we have, I think, try not to have empty draws, but every try not to have empty draw calls. Not every driver handles them performantly. Okay, thank you. I can get around that. It's gonna be trickier, but that's good to know. So we're gonna have early returns because this also does the empty draw calls. Empty draw calls. How do we get around this? Alright, let's finish off one thing at a time. Otherwise I'll forget that I've tried to do. So we just need an extra. Fortunately, that's quite easy to do. And now we're just going to say runtime particles. Particle set. I like this idea because we can just like have you know, different particle sets doing different things. Oops, passed in. Don't know why command buffers come with us here. So now we're going to say particle set 0 is the descriptor set, push constants even. And that should give us a way to set the particle set, which is nice. Oh, we need to also change this. Okay, and particle set is equal to particle set. No, let's just make sure this doesn't exist anywhere so we don't get any shadowing. Okay, it's chill. Yeah, it exists in other places, but it's yep. Yo, Shadow, how you doing, dude? Hopefully your Roblox development is going well recently. Right. Fires, thank you very much. Alright, so particle sets. Then we need to set this up in here, which is in the main, I think. I forgot where I put this. Yeah, watch some of your streams every now and again. I don't always comment though, so sometimes I'm just lurking. I do that for a lot, like I said, I do it for some people, and then just sit in the background. I said draw particles. Where is this then? Where's this function? Obviously it's gonna not work, but I could compile, I guess. Ah, there it is. Okay, so particles set 0. Right. Get off the IB, bruh. What? IB. Alright, so we have particle sets. That's set up there. Let's start some music. I feel like I've not set up the music very well. Alright, so I don't know if you guys like music or dislike music, so I'm just going to send this down to about here. Sure, I'll risk it. I have no idea if this is going to get copyright straight. Not all indie game music is equal. I've been listening to the Death Note music since you didn't have anything on. I see. Sure, I'll listen to this. It is what it is if it gets cancelled, I guess. It's just because lost. Some indie game music, it just doesn't like it, and you just get copyright claimed anyway. But is there a long playlist? It doesn't matter. So I'll just sacrifice one playlist, one live stream to see if this works or not. Yeah, let's see. It looks okay. Often you get like a thing down here telling you that your video's using some music. Anyway, how loud is that for you guys? Is that good? I'll put it up here. All right. Anyway, even had some progress with software rasterization. I was able to understand the edge functions. Yo, nice work, dude. Hi, Luminix. Play NCS. NCS. Not sure what that is. Is that some music? All right. Right. Okay. Let's continue solving our problems one step at a time. I'm sure it's not that bad. Sounds a bit dramatic, that. It's music from 2016. Yeah, it's fine. There's nothing wrong with older music. I wouldn't. Fair enough if you don't like it. I mean, you can say that, but I can't imagine it's the end of the world. You have 100% heard it before, right? Got you. Well, anyway, it's fine. Don't worry, Angelica is a cutie. We'll be listening to this for a bit. I'm not going to change based on. All right, so let's just. I'm going to reconcentrate on what I was doing rather than music. Right, so we need to dive into the. So we have the set. We return early. Now we need to deal with the fact that we're returning early for our draw calls. So, as Ratchet said, we don't want to have empty draw calls because not all drivers handle this performantly. Which means... This is tricky because it needs to be triggered on the CPU. And the whole point of doing this was to actually avoid doing any CPU checks. And now, is there a way to check if something is, like a buffer is empty or something? So actually, let's see. If the draw call count is 0, then we have an empty draw call thing, meaning that we don't want to trigger our draw call. So that's our condition, but how do we check against that condition? What I'm saying here is we have a VK command to draw indirect count. Remember that there's an indirect draw call command that takes in account via a buffer. Yes, we're using that at the moment. So we have our count buffer. So we need to basically not run this if this fella here is basically empty. Now, yeah, because we got this, if you can see that. My question is, how do I know when it's empty? Oh, you can have a 0 in this command. Oh, you can have a 0 count in this command. Oh, and that just chills, does it? Oh, chill beans then. I meant setting the instance count 0. Yes, we do that every single frame. We reset it to 0, but it looks like if we have it to 0, then the draw call count buffer. I assume then the graphics drivers know what to do with that, and we're not going to freak it out by having an empty draw call because we've got a 0 draw call count. Let's see actually what it says. We can just look that up perhaps. Like, can it be 0? I mean, obviously it can be 0, but I wonder. The count buffer, is that mentioned anywhere outside of? Okay. Contains the counts. Maximum number of draw calls and a minimum. Specified in this. Yep. The command will read in the 32-bit integer from this, located in that, as well as the draw count. 0 instance draws can be bad, but passing 0 to the VK. Ah, I see. Okay. Right. Okay. So because we're doing a little extra work here, we're actually sidestepping this issue of having 0 draw calls. Okay, so that does suggest that we are pretty much ready to start beating this up. This song can be a little louder. It's cause it's ambient music. Oh, this song can be a little louder. Would you like it louder? I can turn it up a little bit. How's that? Yeah, if that's too loud, let me know. Then we can all chill. This is quite nice. Yeah, it's quite nice music, to be honest. I don't know anything about this video game, so it's nice. And like I said, I'll sacrifice one for the boys when it comes to this. If it does get copyright claimed. You'll always be heard over it. Got you. Cool. It's a programming game. Okay, right. So of course, gonna have good music. Makes sense. Anyway, let's start debugging this and see where we crash. Right. So we have just make sure everything's correct here. We have a compute shader with 5 things in now. We have the descriptor set passed in, so we can check the particle set age and set it ourselves. And then, yep, everything kind of works. So what I'm going to try and do after is set up another particle set, I think. We'll see. We'll see how that works. That might just completely break everything. Let's look actually at our game. But let's debug this first, actually. Worry about multiple particle sets later being rendered at the same time. I'm going to do that pair draw call because I don't really know how to do that any other way, but yeah. Alright, so what crashes, what goes wrong is our push constants is called oh, did I not do the right size? Oh, I didn't realize. I see. It's using the same. All right, yeah, okay. So that was just me either misremembering or learning for the first time that the struct size is actually the size of what we end up passing in, not the number of elements added together. So I can actually probably just do a size of compute that, right? Because that's going to be 40. I wasn't sure if it was different. So that should get, we should get past that. Now, fingers crossed things don't just completely barf, but we'll see. So we have this, and oh, okay, I didn't see what happened. Oh, interesting. Right, okay, so the first particle gets deleted and then everything kind of dies. I didn't expect that to happen. I thought the compute shader would read it differently, to be honest. It seems like everything gets returned. But I thought we had different data index. This is confusing, honestly. So we have a particle set, which is correct. That did actually work, which was nice. Then we have a size of 1. Then every particle apparently after that gets reset when it shouldn't really do that. That is weird. Why is that happening? Alright, so we have particle data. Your particle data W, which is the time, which is what is correct. Why is it happening for everything? So if I get rid of this, it definitely should work. So it's definitely this condition, right? We haven't set anything else up. Oh, hang on. I just thought, right, if it's returning early, then what ends up happening is this never gets set. None of this works. Which is bad. So I think I mean, we could do subgroup build ballot stuff, but I don't really want to have to worry about balancing multiple booleans and then assigning them a value in a UVec4 and then kind of counting them together, all that kind of stuff. Yeah, we basically exit too early here because we don't generate the draw call. But what we need to do is just basically this is tricky. So, do you see what's happening here? I just wonder if you guys understand what's going on. Basically, as soon as the first particle dies, based on some random value, we stop generating the draw calls. So this only really this has to stop at the end, not at the beginning. So when every particle has died, then we want to return early, not at the beginning, because otherwise we cancel the draw calls too early. If that makes sense, right? Because this buffer is also doing the draw calls. I'm starting to get to this position now where it might make sense to pull these out separately. I kind of wanted to bring them together so I could do this instance thing. Like, nice. But maybe we should do a second compute shader that does something completely different. Because at the moment, this return is breaking this part of the shader. But if they were separate, then we could do that, and it wouldn't affect anything. The downside, though, is still be generating draw calls. So yeah, that's tricky. What I see is that one compute shader does particle physics per particle, and the other generates particles per particle set. Draw calls per particle set. Per particle set, that's actually quite smart. If I keep my instances down to a particular value, assuming that I don't want to do like 1,000,000 particles, no, I can still have the same logic in per particle set, right? I could just be like, all right, yeah, fair enough, same stuff. I think that probably might be the best way forward, actually. Because we can worry about... We can do all the same maths that we've done here, basically. Here. And then we do the physics. Putting both in one shader is going to be a problem. Yeah, I was trying to simplify everything by doing that, admittedly. Hello, just watching. Hello, are you stress testing the particle system as of now? Not right now, no. We are trying to get our particle system to render multiple particles, but also not do the compute work afterwards. After all the particles have disappeared, right? But yeah, I think Ratchet's onto something here. He has suggested that we separate out this logic and a bit of this up here. In fact, we can kind of group this together. And as far as I'm aware, anyway, let's just do a bit of grouping here. Make sure what we need actually is in its own thing. Yeah, and then we can worry about different workgroup sizes. Also, you might end up wanting to use different workgroup sizes for the 2 steps. Thank you for all the reactions. Yes, that is true as well. We can just say 32 instead of 64 or whatever, or 1. We can probably, it's probably for generating draw calls, probably efficient enough to do 1, whereas it's probably multiple, you know, because we're gonna have a lot of these, and like 1. We would probably just want to do... So, oh, did I explain the feature? Yes, so effectively, you know, I want to have like, I don't know, dust. Again, thanks for all the reactions. It's always nice. Thanks for supporting the stream. Anyway, so we want to have like different effects. So like an explosion, but like also space dust and like all the stuff like that, right? Yeah, so these are the things that I kind of want to have, and we need different particle sets to render at different times, and also not do the maths for different particle sets when they're, yeah, let's just say we have 500 particle sets, right? And we have lots of different maths. And let's just say 2 particle sets are being rendered at the current frame. We don't want to be doing all the maths for every single particle set, all the 500, 0 to 500 of them. When we could just be doing it for 2. The problem with that, though, is that we are returning early on our draw calls, so we really need to be filling up the buffers on a draw call per basis. And I think, as far as I'm aware, anyway, if we just make sure we have the particle count and the draw call count set up for our shade. So the instance count, sorry, the this maths works together with our particle renderer. Yeah, okay, so let's do that. Great, I think the story is the first step. Yeah, the story in our game is the duck wants to shoot rocks. I don't really know what the story is, but yeah. Yeah, thanks for all the reactions. It does, as far as I'm aware, the reactions do, I think it flags to YouTube, as far as I'm aware, that the live stream is, you know, it should be pushed to other people, so it does actually help, along with liking the stream. All that stuff helps the stream reach out to other people. So if you want to see the stream grow, and assuming that it doesn't mess up your likes and you don't see all my live streams on your homepage, and that might be annoying, I don't know. Yeah, liking the stream and doing a couple of reactions does help. Yeah, tab crashed. That's me doing it a lot. Thank you, Angelic Rizzacutie. Yeah, exactly, yeah. So, yeah, we're going to have a very simple story. It's going to be... Alright. Alright, what are we doing? Alright, I'm getting a bit hungry, so we might end up eating my food first. So the first thing I've got to do, I think, is figure out how the okay, so that's... How do I want to encapsulate the data on the CPU side? So particle count and particle set need to be tied together. So yeah, let me think. Peak song come up. I need to okay, I need to clear myself. Yeah, it's a pretty chilled soundtrack. It's quite nice. Okay, so yeah, we need to tie these two together, otherwise it's going to be a bit awkward otherwise. So let's look into where we need the particle sets at. We need the particle set in both shaders. So let's write the shaders first. Actually, let's write the shaders. So this will be the particle things and the particle indirect draw calls, I guess. I don't know. I don't really know. You will love Shenzhen soundtrack. Yeah, it's nice so far. Alright, so we need a draw call. So particle draw call, I guess, or draw calls. So particle draw. Particle draw call and a comp. So we need, unfortunately, another compute pipeline. Got ya. Shenzhen has all the red flags. I don't know what an exip. This is Exapunk. Oh, this one, this track, right? Got ya. Very cool. Right. Let me think for a minute. Let's get the shader in. We're kind of just gonna do the draw call logic in a second shader. this does pain me a little bit because this does mean we have another bloody pipeline to set up. But it is what it is. I'm not going to cry about it because that's going to make me... I feel emotional about that, if you know what I mean. It's not a logical decision. In my mind, anyway. So we want to do this. So this needs to happen per particle set as well. So actually both need to happen per particle set. So that's actually good to keep track of. And we need the amount to draw. Let me think. How do I set up this draw call? Oops, get rid of this as well. Alright, so we don't need this here, we need this only. So we still need to draw the amount of draw calls that happen, I think. So let me what I'm trying to say here is okay, so we don't need some variables here. It's hang on a minute, what was this used for then? Draw call count. Is that used in the other shader? Outside of that? This might be like a dead variable. I hope it is, because otherwise we're going to have to pass in the bloody draw call shader. This thing. Okay, good, thank goodness. Hey Void, how are you doing? Yeah, not bad. Just a little hungry, but overall, cannot complain at all. I took a day off yesterday. Speaking of which, I haven't even set up my timer. Boo! So I only did 10 minutes of work yesterday. Trying to lower my stress levels by not freaking out over nothing. Alright. And as far as I'm aware, that's everything? Okay. And that's good. Low cortisol streaming, exactly. I'm terrible. I'm a terrible stress head, honestly, I tell you. It's is there a way, if we're going to store the amount of particles that we're going to draw, is there a way of tracking that in the shader? And on the CPU? I don't know. Maybe, no, I think that's a bit too heavyweight. Yeah, I don't understand how, like, some people exist in on this planet Earth that don't get stressed, which is so, like, impossibly impressive. I don't really get it. I guess they're just stoic chads, and I'm just I don't know, a virgin warrior, I guess. I can't remember the memes. That's my secret, Captain. I'm always stressed. Ah, right, yes. I like it. That's yeah, it's quoting the Hulk, I think, right? Alright. So alright, so that's fine. This is the draw call count. I started learning Unreal. I want to make a tiny realistic game. Yo, nice. Yes, we need more good games out there, so please do. I hope your Unreal goes well. It's funny as well. I've recently kicked off a game jam. I think I talked about this on stream, but I don't think anyone was interested, so I haven't brought it up since. But yeah, feel free to join a game jam. That's always a good way to kick your butt and give yourself a deadline. to make something small. That's always a good move. All right, so let's dig into this a bit. Yeah, the game jam isn't like for game engine developers as well. It's like for everyone. The one I hosted. It started. What was it? It started 4 hours ago, for 2 weeks. I won't be taking part. Just because I have 20 billion other things to do instead. Alright, so we need to think about this a little bit. I also need to make sure that the compute shader... is where I'm a bit stuck, actually. So we know that... oh, yeah, we can just have... no. If I put also this, and I don't want to generate draw calls that don't have anything in them. That's my concern right now. And if I leave this in its own compute shader per particle set, and the particle set still thinks it's trying to render, you know, 10,000 particles, even though in here that everything's past its max age and it's returning early. The problem is I'm having now is how do I stop the draw calls being fed to the GPU to avoid, you know, drawing nothing, because the instance count will be still climbing to the same value based on this, right? But also we need to make sure that, again, this only gets triggered when a what we could do is literally make this inactive active buffer thing, but instead of it having an array of particles in it, we just have a number. If, right, so here's what I'm thinking, right? We have a struct, right? Active. So we might end up doing this, what was suggested in there anyway. And we have two things. We have uint active. Remember, this is per particle set, so per particle set. Or is active, I guess, if it's going to do that. No, active set. And uint inactive set. The problem is with, let's just see what that is. This data index is going to run based on how many invocations I send into the VK dispatch. So if I have yeah, let me actually, you said that you've done it on the CPU side. Let me think about what you've just said. Do I have a way of controlling the instance count here? As far as I'm aware, the instance count gets incremented. Sorry, no, wrong. Yeah, the instance count is assigned here, so it's created here. That can't be done on the CPU side because this is just going to be invocated with the same number of draws, right? So here's what I'm thinking. So to return early out of both shaders, in fact, we probably don't need to split them up now I think about it. But anyway, I might still do that anyway. We have an inactive set, an active set. And if active set equals 0, equals, so if, again, I don't know how I'm going to access this, probably again another buffer device address access thing. We don't need particle data, so I'm just going to replace this with an, I should just replace it actually. So active set data, active set, And this is a read-write buffer. Because we need to be able to read into this. We take the... What did we replace? Particles. This one. And we say PTR. We don't need... do we need that? No, we need a lot less in here. Let's just think about what we need first before we continue. Do we need our particle set? No. Alright. Yeah, we need these and this. So we need these 3. So if, effectively... If... we actually don't want this to be an array, I don't think. So... Because there's not more than one. Oops. Dots. Then we return. Right? That's what I'm thinking. Oh, sorry. Not return 0, but just return. That's what I'm thinking, right? So we basically... Every time in this shader... this happens, or no, yeah, this happens. Instead of returning, no, that's not right. Instead of I think we need a different condition. I think we need the same thing twice. Effectively, we need to return when this is 0, but we also need to then be moving things from one thing to another. The problem is, this is tricky. Because we need to fill it up. No, we don't want to fill it to 0. Sorry, that's wrong. We just need it to be the same. So we don't need the draw command buffer, and we don't need this in here. We need the particle set, that's fine. Get rid of these 2. The particle sets. Okay, so this is the same logic. Effectively, now we need a new buffer in here to move things from one thing to another, right? I haven't quite figured out how we're going to do this, or what the exit condition is for this going to be, but just bear with me just a moment while I kind of figure it out. So we have another buffer, and oh yes, we need the work that we did in here as well. So this needs to be in here. Okay, done. So that's still going to be the same. Then we actually just need active set for now, but I can't quite think. Because this needs to be done for the first time and then returned every single time afterwards. That's the tricky part at the moment. Ah, right. Okay, so if... No, that's not going to work. The particle... The individual particle needs to tell me that it's inactive. This is the only way we know if it's inactive. But the problem is with what I was thinking of, right, is... Right, this is not going to work, because I'm aware. But let me explain why, so I can, like, kind of maybe puzzle it out. Where is it? So active set, right? I don't know if it has that unary operator, so I'm not gonna chance it. I know it has that at least. Inactive set, right? Now, obviously, the problem with this is every time it hits this, it's gonna do this over and over and over again. And we only want to do this once uniquely for each particle. So remember, these aren't like array indices or anything like that. They're just like a number. Now, I need to figure out basically a way to do this once. Only do this once per particle. As you can see, if we did this multiple times, we'd end up breaking it. We could have like an epsilon value, but even that wouldn't work. And this is for each instantiation as well, so this would happen every single time we run the compute shader for nothing to do anything. So we need to do this per per particle, but only once, without making a mess of our adding. We want to minimize how much data we have in the particle data itself, right? We can't have lots of data in here because that would break everything. That would completely rip apart what we've been doing. What do we want? How do we do this? So this is per particle set. No, it's not. It's just active and inactive. This is global because there's no way to tie it to the particle. I mean, we could tie it to the particle set, but there's no way of saying that. I don't know if it's worth it tying it to a particle set or not, because in this it isn't, and I don't know why they did it that way. So I was just thinking about what to do. Okay, so I don't really have any solutions, to be honest. If we only want to assign something once, I feel that this is very data structures and algorithms type deal. Which maybe I do need to go and leak code for like a week or two and drill some basics. I don't want this to be an array because that would defeat the points. What we could do is, instead of having we can make it into an array, right? Where we do kind of something like this, where this is matched one-to-one with our particle data. We just have a separate buffer, right? It seems awfully wasteful if you can just try and get this to work with one. Is there a way though? I don't see it. And even then we'll still end up running the same thing over and over again. What we could check actually, If it was like this, then it would be pretty straightforward to check, because we could just be like, also if, I'm just going to do a second if statement, you know, is equal to 1, then do that, you know, else return, kind of thing, right? Basically, it's like 2 booleans across 2 like massive arrays. Maybe I'm overcomplicating this. Hang on. I usually overcomplicate stuff quite easily, so. Now I had an idea of setting a boolean that's like shared in the other compute shader. It gets flagged when the instance count is equal to less than. But I don't think that works. What we could do is bring everything back into one shader, negative the instance count, and then when the instance count is equal to 0, we don't draw anything. But we need to make it the instance count persistent. I think that might work. So let me, I know we're just going to kind of go backwards here. But here's what I'm thinking, right? So we have the instance count here, and that is based on that. But if we have a way of saying that when something dies, we add something up, and then we subtract it from the instance index, then it kind of like evens out, because then we can just reduce the index. Now we get the same problem though, still. Because the problem is the threading part of this is where we have multiple instances of this running. It's not like a regular program where we can just rely on this to run once, or even in a for loop, right? That's why I'm struggling with this a bit. Effectively, we have a undeterminate size, an indeterminate number of threads running this thing, and we could end up in here like 6 times, and then like, yeah, I don't know. The data is kind of complicated. But effectively what I'm trying to work with right now is the instance index, so the instance count. If we reduce the instance count based on how many inactive, or how many times we're in here, then we've basically solved the problem. But unfortunately that just kicks the can down the road, not to So, for example, instead of that, right, we say, okay, instance count. So we don't have this. What is this max instance? Oh yeah, this is just 9,000 and 199,997. That's the instance count. Oh, this is so tricky. Guys, don't try and get good at graphics. You know, get good at anything else. Get good at ballet or something. Get good at being a circus performer. Something useful. Oh, this is so tricky. Don't tell that. Don't be like me and write stupid allocation algorithms. Yeah, exactly. I'm so tired of this. I don't blame you. It's tough. I mean, like I said, I wrote like the most basic versions of all that by just using a library. You know, I didn't really do much, but you know, it's listen to Ratchet and I. Any viewers who may be watching, get good at basket weaving instead. We're very close. Kind of been working for 3 hours on a single function. Yeah, that sounds about right for what you're trying to do. Yeah, I've been staring at compute shader now for how long? Oh yes, we missed the initial. I'll have to kind of match it up with the stream. All right, so all right, cool. I thought it was the same music again. Right. I don't know. We could reduce this, but this needs to be prime. The instance count isn't global anyway, so this doesn't work. My idea was kind of dumb. Yeah, if there are no active shaders, is there a way to figure out work group size versus number of work groups? I don't know what this number even comes out to be honest. Let me think. I think I've got an idea that it might work. We basically count how many shaders get... Sorry. No, it still doesn't work. The problem is this if statement is going to be ran multiple times. If we do anything in it, It's going to happen every single time there is a particle has exceeded its age limit. Meaning that this is just does not matter. It will just constantly be doing stuff. So if I put anything in here other than a return, it has to be a return. There is no way around it. Now, what we could do, in fact, is do the condition twice, right? This might be the way out of it. If we do the condition twice, then this will only get ran once, because the next time it's ran, it'll be returned, because this is the time it's been added, right? So, or if we take new position, actually, we can just do it like this. It's equally as chill. So now we have something that's going to happen per particle once, because every single time afterwards is going to be hitting here instead. Meaning that we can do something about this inactive active idea. Now, do we want to have a buffer that's shared between things, because then we want to do whatever, right? Okay, so let's just do the simplest thing. We want to add a number over and over again to a value. And if we don't have a buffer, then so we could have a second buffer that just has these in. No, let me think. No, just make things take just as long, but we're getting close. We need something to happen in here that's like useful. I need to add a number to a variable that's persistent between each instantiation. Now the problem is with, as far as I'm aware, shared data like this. Sorry. Yeah, inactive particles. You can't do this. This is not allowed. You can't do an assignment. And the problem is afterwards. So when I add 1 to a value, maybe I need to set like a shared. If I can do a shared int just between instant. I mean, like I said, I could just make another buffer, but maybe that is the way forward. We just fill up a buffer with a bunch of zeros. Sorry. Yeah, we just have a second buffer which just has an inactive set of particles. I don't know if it's per descriptor set yet. No, particle set. But yeah, let's make a simpler buffer. Let's do it like equivalent to the draw call guy. And oh yeah, we need to split this up again. Now we've figured out how we're going to do this. Yeah, we definitely need another buffer, because otherwise we're going to be in the same situation again as soon as we hit return, the early return here. So I'm glad I kept everything around. So let's get rid of everything that's not relevant. So we don't need these. So we do need an inactive and active buffer, right? This can go. Just make sure that exists. And yeah, it does. Okay. Okay, so inactive, active. Because we can always clear this out once at the beginning of the frame at load time. Oh my goodness. Okay. I'm gonna stick on a video. So we are streaming now, which is nice. Thank goodness. I don't know what to stick on. I almost just want to stick on like anything, honestly. Let's pick something else. Yeah, let's do. I don't know how to do ray marching. Actually, literally no idea how to do this. I don't even understand the concept. Is marching it? Not marching. I don't want it to be too short or too long. This is a bit long, honestly. Alright, we'll just we'll pick on this one. Pause that for a minute.
Since the beginning of 3D computer
graphics, just start the audio.
Used as the building block for rendering complex scenes
up.
and objects, triangles. These three-sided shapes are at the core of the vast majority of 3D video games due to their many interesting properties.
Right, I'm gonna let this run because I'm getting really hungry. And I will we'll learn a bit about rain marching because I've never done this before. And yeah, let's get some food. Let's keep crushing it. I'll be right back, gang. Just get my food. Okie dokie, nearly done. Got a long trip to the kitchen. Alrighty. Yeah, so we're just gonna watch about rain marching because I keep ray marching. And we'll see how this goes. Procedural generation of whatever.
It's the shape that can form a polygon with the lowest amount of vertices. They are both computationally and memory efficient, and all modern graphics cards are specifically designed to process triangles in parallel. Generally, the more triangles you can process at a time, the more detailed your 3D models and environments will be.
All right. So I'll go
rendering
push
all of these
usually
triangles on the screen is done through a process called rasterization, which comprises 3 main stages. In a first place, a vertex shader will transform the vertices of each triangle from 3D world space coordinates into their 2D screen space projections using the current camera position and orientation. The actual rasterization stage.
The channel's there. Kishimisu, I don't know.
Happens after this step and takes these.
The also translator probably broke you there. vu. No idea what that means.
Screen space vertices in order to calculate which pixels of the screen, also called fragments, are actually part of the current triangle. Finally, the fragment shader processes each of these fragments to calculate their final color displayed on the screen. This part generally uses information from the vertices and external light sources to shade the pixel accordingly. This process is done.
Oh, it's an AI voiceover. Am I cooked that I can't tell? You are right, actually, it is a bit odd. Alright, we'll just skip it then. Screw it, we'll do sign distance.
If you want
function.
to render a 3D scene onto a 2D screen,
AI
basic setup is the following. We imagine a camera in the scene, which projects everything onto a rectangle, representing the screen in front of it. There are a few variations on how to do that. Here, we will follow a straightforward approach, pun intended. We connect a pixel coordinate of the embedded screen with the projection center to form a ray and send it out into the world. We check whether and where it intersects an object. Only afterwards we worry about how light reflects there and color the pixel we started from based on that. Then we do this for all other pixels too. In this video we will focus on the first part, finding the intersection point, and only touch on the lighting issue a little at the very end. I'm Bernhard Werner, and this is a video on the basics of sign distance functions and ray marching. The crucial part in the process just mentioned is that we can actually intersect the ray, which is basically a straight line, with any object we have. For simple shapes like spheres or cylinders, this could be done explicitly. For more complex ones, this is often made possible by modeling them out of small triangles. Then, to check if the line and a triangle intersect is relatively simple and efficient. However, even if we have plenty of little triangles, there will always be a discrete approximation. There's nothing wrong with that per se, but in this video we will now try to model complex objects in a way that uses as little information as possible and give precise intersections. We won't fully achieve that though, and end up with an approach somewhere in between the two cases up on screen. Let's look at this 2D diagram to get a better overview. We still want to shoot a ray out from the camera in the direction of one of the embedded pixels. But we assume that we know nothing about the objects in our scene so far, so let's turn off the lights. Imagine you are standing here at one of the pixels. You would like to know how far you can march along the ray without hitting something, and I will help you. But all I know is where you are, not in which direction you are going. So I tell you the following. One object is 2.2 units away from your position, the next one 5.1 units, and the last one 11.2 units. How far can you go? Just 2.2 units. You can be sure that within a sphere of radius 2.2, there isn't anything you could bump into. Well, right on the border of the sphere there is at least one point of the first object, but if we landed there we would have found the intersection we were looking for. Importantly, on the way to the border of the sphere you won't hit anything. After that we iterate. I again tell you the distances to all objects, you choose the shortest one and walk forward by exactly that amount. Let's turn on the lights again and think about what happens if we do that over and over again. After passing everything vaguely to the sides, you will approach the point where the ray hits something. Unfortunately, unless this part is perpendicular to the ray, you will move at an angle towards it and you will never reach it. There are two ways to think about this. From a purely mathematical perspective, you can just take the limit and do actually infinitely many steps this way until you end at the hit point. For a practical solution, you just stop if the last step you made is small enough, say 0.001 units or so. That means that technically every object found like this is a tiny bit too thick, but that's usually not an issue in practice. We have seen that the so-called ray marching algorithm can find the spots at which the rays connecting the camera and the embedded pixels hit an object. There are two major issues that crop up with that, which I quickly want to address here. Firstly, we have to think about what happens when the ray runs past all objects. With our current algorithm, you would continue to march on using bigger and bigger steps. In this case, you could limit the number of steps you make. If you found nothing after, say, 128 steps, you conclude that the pixel you started from must depict the background of the scene. Another possibility is to check whether the current point you're on is a certain maximum distance away from the camera. You stop if you are past that. In practice, you probably want to combine both ideas. The second issue that can occur is that we may have many objects, and calculating the distance for each of them multiple times might slow everything down, especially if you want to do it in real time, like for example in a video game. To fix this, we can subdivide our space into boxes and record which objects are in which boxes. If we then have a point for which we wish to calculate all the distances, we can limit ourselves to the objects that are in the box the point is in or in a neighboring box. This subdividing into boxes can be done smarter via so-called octrees. Instead of explaining that, however, we will now look at how and why the distance information we used is interesting to work with before coming back to actually rendering stuff on screen. You can take any set in the n-dimensional space Rn and define the distance to it from any point like this. You look at all points in the set and calculate their distances to the given point. Then you take the shortest distance and that's it. The individual distances are, at least for our purposes here, computed via Pythagoras theorem. In particular, any point in the set has distance 0 to the set, as its distance to itself is 0. To model objects with it, to be rendered by array marching, it is more practical to consider the signed distance. The idea here is to calculate the distance not to the set itself, but to its border, which is written with this curved D symbol. We take the distance to the border if the point we are interested in lies outside our shape, but we take the negative distance if it lies inside. And on the border itself, it is 0. Defining the border, the inside and the outside of arbitrary sets can be a bit technical, but in this video we only consider quote-unquote reasonable shapes, so border, inside and outside are what you think they are. There are two reasons why the signed distance is more interesting than the absolute distance. Firstly, it allows us to manipulate and combine shapes in more intriguing ways. We will see that in a few minutes. Secondly, the calculations we will do will often give the signed distance directly instead of the absolute distance. In this video, I will depict these signed distance functions by drawing the border of the shape in question as a white line. Outside and inside, I will use gradients to show how the distance gets larger step by step. Looking at this, you might think they look like topographic maps used for hiking and such, and you'd be right, it's basically the same thing. We will come back to that interpretation later. For now, it's only important to realize that the curves made visual this way are so-called level sets, or isolines, the set of points that are all the same distance away from our shape. In particular, the border itself is the level set of distance 0. The way we define the signed distance here doesn't tell us how to actually calculate it. Checking every point in a given set is of course impractical, and for an arbitrary shape there isn't actually a nice way to compute it. But there are numerous primitive shapes we can calculate the signed distance functions of, and there are ways to combine them into more complex shapes. I will show you a few examples now. For a much larger list, have a look at the website of Inigo Quiles, which is the gold standard of resources on signed distance functions. He also has a fantastic YouTube channel where he shows how to use SDFs for actual modeling. Links to both the sites in the doobly-doo. Since I'm terrible at actual modeling, I will focus on simple shapes to explain the math below. So do check out Inigo's work to see how all this can actually be used in practice. Moreover, I will only show you 2D examples. For many of them, it's straightforward to adapt them for the respective 3D shapes. For all the following calculations, we assume that the point P we want to compute the distance to different shapes for has coordinates x and y. Let's start with the arguably simplest shape, a circle centered at the origin with radius r. We can calculate the distance to the center by the Pythagorean theorem. We then have to offset it by the radius. This expression might look quite familiar to you. It is very similar to the more common circle equation x squared plus y squared minus radius squared equals 0. And this is a good opportunity to stress the following point. There are infinitely many functions that are 0 if and only if the input lies on the circle. But we want more. We want every function value to have a particular meaning, namely describing the distance to the object. If we were only interested in describing the border, there would be many more ways to do so. Let's go to a different shape. A straight line. If we assume that it is given by a point Q on it and a normal vector n of length 1, then the distance is given by this linear formula here using the scalar product. Setting this expression to 0 gives the so-called Hessian normal form of the line. In contrast to the circle, this common way of describing a line is already the distance, at least as long as the normal vector is actually of length 1. Note that due to the way we define signed distance functions, this is technically not describing the line itself, but the half space bounded by it. For the actual line, we would have to take the absolute value of this function. Next, a class of objects ubiquitous in graphics programming, line segments. If P is beyond the endpoints E and F, the distance we are looking for is the distance to the closer endpoint. If it hovers somewhere over the middle of the segment, we need to find the length of the perpendicular vector that connects the point to the segment. For this case, we could use the same formula as for lines, but with a small algebraic detour, we can also find out in which of the three cases we are along the way. We calculate this value lambda here via the scalar product. It will run from 0 to 1 as the projection point of P onto the segment runs from E to F. In this case, we get the desired perpendicular vector V as this linear combination here, and the actual distance as its length. Moreover, lambda will be below 0 if P moves beyond E, and bigger than 1 if P moves beyond F. So this value lambda not only allows us to determine the distance if we are in the middle case, it can also help distinguish between the cases. Instead of doing a distinction by cases, however, we can do something clever to combine the three cases. When the fraction of scalar products is negative, we are beyond the endpoint E, and we need to take the length of P minus E. If we look at the definition of V, we get that vector if lambda is 0. So if we can set lambda to 0 if the fraction is negative, we would have incorporated the beyond E case into this one. And we can do that by setting lambda to the maximum of the fraction in 0. If the fraction is bigger than 1, we are beyond F, and we would like V to be exactly P minus F, which we get if lambda is exactly 1. Similarly to before, we can achieve this by taking the minimum of our value and 1. This way, the resulting vector V will always give the distance no matter in which case we are. And we get a relatively simple formula for the SDF of a line segment. As a final example for now, I'll show you the signed distance function for a so-called axis parallel rectangle centered at the origin. That is, a rectangle where the sides are perfectly vertical and horizontal, respectively. Here we can use symmetry and mirror everything into the first quadrant, i.e. we replace our point P by a point Q by taking the absolute values of the coordinates of P. We assume that the size of the box is given by the position of the top right corner, which we call B. Then we can express the distance of Q to the box by looking at the vector V from B to Q. Firstly, the point Q could lie somewhere to the top right of B. Then B is actually the closest point of the rectangle, so we can just take the length of V. Secondly, Q could be right above the box, and we would need to project down again, similar to the line segment from before. But since the rectangle is parallel to the axis, the distance is just the y coordinate of the vector V. And the x coordinate of V tells us when we actually are in this case, because then it points to the left, and so the x coordinate must be negative. We can now use this fact that the coordinates of V play entirely different roles and combine cases again. We can build a new vector u by rounding the x coordinate of V up to 0 if it is negative. When V points to the left, its tip is effectively pushed right until it's vertical. Then its y coordinate coincides with its length, and that is the length we want. And if we are in the top right again, u will be the same as V, since its x coordinate is positive and we get the same as before. Thirdly, the point Q could be somewhere to the right of the rectangle. We can use the same argument as just now and shift V upwards by taking the maximum of the y coordinate of V and 0. That means as long as the point Q is outside the box, we can look at the vector V, round its coordinates up to 0 if they are negative, and take its length as a single formula for all three cases. Inside the rectangle, the coordinates of V themselves represent the distances to the edges, so we can just take the smaller one. Well, the bigger one, since they are both negative, and we want the distance to be negative on the inside. All that's left is to find out whether an arbitrary point Q actually does lie on the outside or inside. Note that the outside distance we computed is always positive, and the inside distance is negative if and only if the point lies on the inside. That allows us to take the minimum of the inside distance in 0 to actually limit it to negative numbers. But now, the result that's coming from the wrong case will just be 0. That means we can just add them together and don't need to worry at all which case is the currently correct one. Long story short, we get the SDF of an axis parallel rectangle without ever having to check where points lie in relation to the rectangle. There are many more SDFs you can compute with a bit of effort, or you do the same as I and everyone else and check Inigo Quiles' website. There you find moons, hearts, crosses and many more. In order for all those SDFs to be actually useful, we need to be able to transform them. For example, we only considered circles around the origin, but we might want to move them somewhere else. We only have the SDF for axis parallel rectangles, but we probably want to be able to rotate them. Take this set here and assume we know its sine distance function d. Then we apply a rigid transformation to it, which is a combination of a translation and rotation. That means that the shape itself doesn't change, just its position and orientation. If we then take this point here, for example, and try to find its distance to the object, we can move everything back to the original position, i.e. we apply the inverse of f. Since these rigid transformations don't change distances, we can evaluate the SDF we have, namely d, at this pre-image of p under f. Since that works for every point, the signed distance function of the transformed object is the original SDF d concatenated with the inverse of f. This way, we can move objects for which we know the SDF freely around. Another way to change SDFs is by making the shapes rounder. Take this rectangle for example. If you subtract a small number r from its signed distance function, the corners get rounded off. Depending on your use case, you might have to compensate for the change in size though. As another example, if you start with a line segment and subtract a number, it turns into this capsule-like shape. This works for any SDF, but is most relevant and interesting for objects with actual corners. There are more ways to manipulate individual signed distance functions, especially in 3D. Next, however, I want to talk about how to combine them. Take these objects here with SDFs dA and dB. We might be interested in the SDF of their union. Consider an arbitrary point. One of the two parts is closer than the other, so that must be the distance to their union too. That means the SDF of the union is just a minimum over the given functions. Except it isn't. If you look at the inside, you might see that the isolines don't ripple inwards properly. Take this point here for example, and let's see where the boundaries of our starting shapes were. The closest points on them to the yellow one are to the bottom left and right above, respectively. The closest point of the boundary of the union is this corner here, however, and it is farther away than the other two, which are used to calculate the combined SDF. Hence, we get a distance that is too small, or here too large, since we are in the inside and everything is multiplied by -1 there. We could just ignore this, because in the end we want to render 3D objects we see from outside. But unsurprisingly, the next thing to look at is the intersection of our two shapes. With a similar argument as before, we can get it by taking the maximum of the given signed distances. And now the outside is slightly wrong, for very much the same reason. You can see that if you compare the top left and top right corners of the shape. Depending on your use case, it might not be a big issue. For ray marching alone, for example, it mostly means that we need more iterations. The correct SDF for this object would look like this. Look close at the ridge coming out of the top left corner. But in general, just taking the maximum will be wrong, and there's no way to fix it for arbitrary signed distance functions. In practice, there are ways to work around this problem. In the example on screen, I intersected the circle.
We're just watching this super cool video about SDFs.
Not with the rectangle we started with, but with this pentagon here. But that's more of an artistic approach. You think about the shape you want to end up with, and then you look for a way to get it. From the math standpoint, it would be nice if we could properly intersect any two shapes via the maximum. Alas, we can't. Moving on to the last operation, we can cut out one shape from another. If we take the negative of the circle SDF, we basically say that the inside should be interpreted as the outside and vice versa. If we now intersect it with the rectangle, we cut away the part where the original shapes overlapped. And here, the level sets clearly look wrong. There's more to say about these three operations. Moreover, they aren't the only ways how to combine signed distance functions. And we have seen that one needs a clear plan which shape one wants to end up with to use them properly. But I hope you can now imagine how it might be possible for complex shapes to be built from simple ones using SDFs. Instead of talking more about the technical aspects of these functions, I now want to go back to our initial problem of rendering 3D objects. As explained at the beginning of the video, we imagined a screen to be embedded in our scene. We send out a ray from the camera towards every pixel and intersect the ray with several objects using ray marching. Based on the point we hit, we have to decide on a color for the pixel. Let's start by making a pixel white if we hit something and black if we didn't. If we now let the camera rotate, you might already be able to recognize the objects we saw at the start. A capsule, a frustum and a cube. Currently they look very flat though. To make them look more three-dimensional, we still calculate the hit point with an object in the direction of every pixel, but then we calculate the distance of said point to the camera. We color the pixel white if the point is less than 60 units in front of the camera, and we color it black if the hit point is more than 90 units away. In between we interpolate with gray values. The result already looks much nicer. We could tweak this a bit, but this is basically the full information of how our objects look like seen from the camera. At least if we are only interested in the pure geometric information of the shapes. But, as I mentioned in the beginning, we could also take a couple of light sources into account. Lighting models are a big topic however, so I don't want to actually talk about them here. There's one bit of information however we need for lighting calculations that we can extract from our signed distance functions, and I want to show you how. When light reflects off a surface, it happens in two major ways. For shallow angles, the light reflects fairly cleanly in the opposite direction it came from. It spreads only a little, depending on how smooth the surface is. Or, for steeper angles, it scatters in all possible directions, but mostly upwards. The first is called specular reflection, the second one diffuse reflection. To model either of them, we require the normal vector of the surface. That is the direction that points straight up from the surface at the point the light hits. Let's see how we can get this vector for our signed distance functions. For the 2D case, they are functions that take a point in the plane and give back a single real number. So their graph can be depicted as a surface in 3D space, where the x and y coordinates represent the input and the z coordinate the output. Recall that a set of points that all map to the same value is called a level set. We can visualize it here by intersecting the graph of the function with a horizontal plane. If it sits at z equal 11 for example, the curve in which it intersects the graph represents all points that are mapped to 11. And we already briefly talked about how for signed distance functions, the border of the defining set is just a level set at height 0. For all reasonably nice functions, the direction perpendicular to any level set is the direction of steepest ascent. i.e., if you imagine the graph to be a hill you walk on, you can walk along a constant height, and if you turn 90 degrees, you will face the direction where the hillside is the steepest. Maybe you've experienced that yourself on an actual hill. If you take this point here on the second visible level set for example, we can move it around, and the upward direction of the quote-unquote hill will always be perpendicular to the level set at that point. And if we go back to the flat depiction of our SDF, we see that this direction is still perpendicular to it. The important fact for us now is that this direction coincides with the gradient of the function. It is defined as the rate of change in the x and y direction. We walk a tiny distance epsilon in the positive x direction and the same in the opposite direction, and compare the differences in the function values relative to the total distance walked, i.e. we divide by 2 epsilon. For the y direction we do the same. In math, we would now need to take the limit of this as epsilon approaches 0. For coding, we can simply take a really small value for epsilon and plug it in. Note that in practice it is often more efficient to explicitly calculate the gradient for the primitive SDFs you want to use and then alter and combine them similarly as to how the SDFs themselves were altered and combined. But this numerical approximation here always works. To wrap up the video, I will, as I already announced, skip all explanations of the concrete lighting model and just show you the result. But I'll link to the Wikipedia page of the model I used in the description. Here, we just need to know that it needs the normal vectors of the objects, and we just saw, at least in 2D, how we can obtain them from the SDFs. In 3D, the calculations are analogous. Here's the version we had before. If we color the background and give each object a bit of base color due to ambient light, we get this starting image. Adding a red light that shines towards the right, a green light that shines to the left, and a blue one that shines downwards will result in this render of our scene. There are many more applications of signed distance functions. One you have
Yes, this is my new accent.
seen throughout the video is to depict shapes in 2D. Another application is rendering fonts, and there is a link to a blog post on this topic in the doobly-doo. Lastly, you can use SDFs for collision detection in, for example, physics simulation too. But the rendering of 3D scenes via ray marching might be the most famous application. With that, thank you for watching, and until next time.
That was insanely good. Why? Okay, that video does have a lot of views. Nice. Yeah, I almost ended up watching a bloody AI video. So yeah, let's give that a downvote. All right. That was nice. No, that was just someone's accent. And it was too advanced. Typically, the video that we ended up watching before was like talking about what the vertex shader does. It probably would have gone on and on and on about that. So yeah. Let me just. That was really interesting. That was actually really interesting to know. It's funny to see the gradient function again. I think the gradient function pretty much always seems to turn up when you don't expect it. Intrigue and transformation engine for that game OST is peak. Chemistry music, nice. Yeah, we'll I'll put that on shortly. We got all the way through all these. We'll be continuing onwards. All right. Let me just clean up. I'll be right back. I'll probably head to the loo as well. So I'm just gonna go BRB. Sorry to be a bit of a bore, but then we'll be attacking our compute shaders once more. All right, should be good. Let me just squidge over. Oh, that's gonna be way too loud. Let me turn that down. Let's just see roughly how that looks. Just a bit less. Okay. Cool. Let's see how my game jam is doing. There we go. I started a game jam. I thought I'd just show it off real quick. Anyone can join this, but it's it's for typically people who are using game engines. So if you were to use your own game engine, you'd probably be a bit stuck. But yeah. I like the early 2000s aesthetic that I pulled off here. Very nice. Haskell game for the jam. Yeah. I have this like other Discord community that I sometimes manage. So sometimes people are like, oh, we want to do a game jam. I was like, all right, let's make a new one. Anyway, what have we got then? Right, okay, so we figured out in the... Hey, game jams are really nice for stress testing your engine. Yes, that's true. I think... You know what might be good? Thinking about it, stress testing type thing. Maybe because there's a lot of engine developers in our community, which it's not as appropriate to say. Let's pause for a minute. It's just an idea. It's not as interesting to say make a game that's the theme is force or forces, right? Because make a game is a bit too... It's also quite difficult, you know, for a game engine developer. But what might be cool is we run a game jam, but it's more like render as many things, render something really difficult in 2 weeks, right? Maybe I'll give you like a little stress test. Like render 10,000 moving objects all at once kind of thing, you know? Like that would be the theme. It would be like render 10,000 things. I don't know. That seems a bit more like game engine-y. Whereas like this is a bit too vague. But anyway, I mean, I could implement that. I could just say, oh, forces. I'm gonna put loads of forces in the game engine, but yeah, it usually doesn't go very well for me when I do that. But anyway, that's something I was thinking about. I've tried multiple times to do the game jams, but fuss or die, yeah. You can see, sorry to yap about this for a bit, but you can see in my itch.io, like all these games, this, and this are all game jam games, and they're all pretty lackluster. You know, like you can see the quality was improved. Well, maybe not this one, but you can see the quality was like it's slowly getting better, and then it didn't quite. Lost Souls is better than some of these, but you know, like some of these games are pretty bad. Like Triangle is literally just a triangle. This rendered, yeah, because I was in the middle of like starting a game engine, and so for the game game jam I made it render a triangle, right? It's very difficult. That's all I'm saying. It's to make games in a game engine. And this was kind of like I made this game in 1 hour. It's rubbish. But anyway, that runs on Linux. I don't think it does, but whatever. Anyway, fun times though. It's all fun. And I've also experimented with game jams when it comes to like the amount of time I spend on them, but you're competing against people who are using game engines in teams typically, and it's just not feasible. Finish writing the allocation function. Now I can write the free and implement resizing. Ooh, resizing's a bit tough, but free should be the opposite, right? It should just be going the other way. Well done, by the way. How did you actually allocate memory in the end? Like, where does your memory get allocated to? I would be curious to know. Obviously on the heap, because, you know, where else would it go? But like, how do you implement the heap? I'd be interesting. Anyway, okay, so we have this idea that we can run this thing once. We need a there are tons of gaps in my game, but I also don't have enough to have a playtest. So I'm just going to rush and add maps. My memory is allocated physically in a Vulkan buffer. Oh, interesting. Okay. So you're using Vulkan primitives. Wow. I thought you were just doing a generic allocator. Didn't realize what you were doing. Interesting. That's really cool. Alright. I really just need... This is the vertex buffer allocator I was talking about rewriting. Oh, okay. Did you need to make it thread safe? What was wrong with the old one? I actually can't remember. Sorry, I'm talking to... Instead of... I ended up writing a free list based best fit algorithm. Less memory but slower algorithm. Slow allocations. Yeah, was this to make it thread safe or something? I've never had a problem with vertices, to be honest. I guess I haven't messed with textures, so I don't have any compressed textures to deal with. Sorry, my textures take way longer. As you know, I'm using STB. Anyway, let's But well done, by the way, Richard. To make it thread safe and less stupid, got you. Yeah, I don't think... should I thread... Yeah, I've never actually done the threading on the actual pulling of geometry. Right, so... Anyway. Hi, Comfy. How you doing, dude? Thank you for joining us. Hopefully you're having a good day, my guy. We are currently in the middle of trying to we're trying to count how many inactive what are they called, particles we have. And because I'm trying to render lots of particles, but I don't want to trigger the geometry, sorry, the shader to okay. Yeah, I don't want the compute shader to constantly work out positions of particles that have been deleted effectively. My implementation is slow as hell, but it's 3x faster than the old one by default. Wow, jeez. Well done. Yeah, I stick it all in the stack. All my vertices. Well, what I call stack is it's a, because I have a memory pool, so I just stick it. So I stick it on the memory pool, and then just pop and push stuff. I think you've seen it before. It's yeah, it is what it is basically. I don't have any way of threading it because it's all kind of sequential. There's no way to like stick a thread in there to pull out vertices, normals, and you know, something else. Escape point. This handles GPU allocations. I've already a staging memory pool. Oh, what are you? Yeah, I literally just create them after. Like, I do it single threaded, I think. So I assume you're. Let's go to the bottom. When you're doing my equivalent here of this, you're doing like a threaded version, like for all this stuff. Is that right? Comfy has said, this stream was recommended to me even though I don't really have any game dev experience, unfortunately, but I have to say that you guys seem very chill, and I'm doing all right. Fantastic! Thank you for joining us. Yeah, anyone's welcome. If you if you do want me to explain something, I am totally fine explaining literally anything I do. So, you know, if you're curious about what we're talking about, or you're interested in some technology or something like that, if not, you can also just you know, chill and vibe in the background. That's also chill. But you know, feel free to reach out if you are interested in something and need it explaining. The also clicker worked. There you go. Yeah. Yeah, because what I do for my vertex buffer, I literally just grab it all off and then just throw it in a buffer right at the end. Per submesh. So, as you're probably aware, each mesh has like different materials and it has its own thing. So it's done per primitive, which is, I think, called I would call it a submesh. I don't know why it calls it primitives. And then, yeah, we create an index buffer and a vertex buffer. It's a fake vertex buffer, though. It's not a real vertex buffer in the same sense of a regular vertex buffer. Thanks, man. Yeah, no problem at all. Yeah, everyone's job in here is to, you know, have a good time. And if I can help you, you know, understand what's going on and make your time more enjoyable, then, yeah. I have one big buffer for vertices, so I can draw everything in one indirect draw call easily. This allocator is to sub-allocate from... Ah, okay, right, makes sense. So I see. So yes, so you're trying to make it so all the sub-meshes are in one buffer. Got you, okay. And it looks like if you have default textures for everything, sorry, materials that you've already sent in, so you have so yeah, that will definitely reduce draw calls though. And you wanted to thread the everything up. Yeah, I'm kind of curious about my own draw loop. Hang on. It's not quite indirect yet, so it's kind of like old school. So yeah, for each model, we have the model type. But this is the actual. So you would be, if I look at this. So we have. So is this code for a specific game, or is it for learning? It is for a little space game I'm trying to create. I think I will have it available for you to see if I run my release build, assuming that I haven't changed anything and broken it. So ignore the terrible menu. This is a 2D renderer. And yeah, it's if you turn off the debug geometry, we have a little asteroid field. We're going to be flying around. We're trying to work on the particles at the moment, so so we can actually do, you know, make things look a bit nicer. So there we go. That's what we're trying to do at the moment. It's not yet that exciting, but yeah. The poop asteroids, indeed. I'm gonna force you to be my code slave. Escape point. Got you. Have to say the test build looks awesome. Thank you very much for one scene. Yeah, we're gonna add like hopefully nice. Nice, you know, nice effects. No, this is exciting. Oh, okay, cool. Yeah, maybe I shouldn't be such a negative Nelly. So yeah, what is a So I have this struct that is an array of models that get drawn for each draw type. I did this because it's really interesting actually the way you've done this, Ratchet. You've basically removed the need for let me think. Yeah, this second for loop, you've got rid of it. You kind of go through each model and you just render each model, I assume? Or are you doing even that? You're combining all the models together, not just the submodels. Are you working with VX? No, I'm just working with straight Vulkan. You can draw everything in one draw index, blah blah blah. Got you. I assume that means models. I see. Very nice. Wow. Last question before I go back to compute shaders. Is there I actually don't know this, so this isn't me like trying to point out a flaw or anything. Is there a point at which having one draw call becomes a drawback rather than a benefit? Yeah, there isn't a draw loop per se. Yeah, that makes sense. I was just wondering if you knew more about it works, because it's quite impressive to me. Yeah, I don't know much about DirectX, to be honest. So yeah, I don't know what's going on. Yeah, DX. If you didn't know what DXVX is, it's just I believe, as far as I'm aware, it's like a conversion layer between DirectX and Vulkan. But yeah, we're just straight Vulkan because I don't need to worry about DirectX. That's effectively what we're up to. I actually have 2 to 4 indirect draw calls for optimization reasons. Depends on the pass. Yeah, got ya. Alright, I'll leave Ratchet alone on that one. Thank you for explaining stuff, by the way, Ratchet. Because Ratchet was just telling us that he has, the guy in the chat, he has combined all his models effectively into a bigger buffer, meaning that he can, it's called a vertex buffer, which just, you know, each shape has vertices, and we call it a vertex buffer even if it's technically not a true vertex buffer. And that just stores each individual, like, you can think of it like each corner of a model, because everything's made out of triangles, so each triangle corner. So what he's managed to do is, instead of having draw calls like I do, where I kind of have like sub meshes and like larger meshes, kind of all doing draw calls like that. So I have individual bits being drawn independently. He's managed to get a system where all his vertex data is in one buffer, meaning that he can do less draw calls. Now, why does that matter? Well, less draw calls is typically more performant, up to a point. So you really often are trying to reduce the amount of draw calls per thing. And you have different passes, which means just, you know, each part of the scene that is rendered has its own kind of job. And sometimes you're doing a shadow pass, like it's being mentioned in chat, meaning that you render the shadows and then you render the, you know, the actual geometry. So that would be another pass, right? Rendering the geometry. So yeah, that's kind of the basics there, and that's what I was kind of interested in. It's cool stuff. Well done. How long did it take you to make the test build and have it up and running? This one took me a while. Probably, I've been slowly getting better at it. So this test build Probably took me 5 months, maybe. Yeah, it's so he's got like a really good renderer. Anyway, but you know, I've been like I said, I've been slowly incrementally getting better at this, making it more and more better. So it hasn't, like, I haven't just been, I got it working yesterday, 5 months, you know, 5 months in. All right, so let's tackle this a bit. Yeah, that's true. I did a lot of studying. I've been doing a lot of studying. And yeah, let's keep going. Let's see. So we have this draw call idea. We need the instant. We have an active set and an inactive set of particles. Yeah, I spent most of my time on graphic stuff, so now I have to work mostly on engine code. Yeah, it makes sense. I'm on graphics, I guess, if I'm doing particles. So we want to return early, and if we have the size exceeded a particular value, then we want to, okay, so let's make this in here. Let's take this buffer code in here, and yeah, we take that out, and we're going to go in here and put this here like that. Yeah, I've been doing physics as well. So you can bounce into the asteroids and stuff like that. I just have the no clip camera on, so I wasn't able to show you. Mostly just so I can demo stuff. But I definitely don't have the same. I'm not in the same position as Ratchet when it comes to his loading of things. That's kind of, yeah. I'm dead impressed, as usual. Right. I've been focusing mainly on trying to get the game kind of working, rather than working on tech, which is good and bad in a particular way. It's not always good to do that. The problem is here I need to think about is this game going to be for mobile? No. It's a bit too new. I know it seems weird to say this, but it can be rendered on mobile, don't get me wrong. It's not like the graphics are particularly impressive or anything, but the fact that I'm expecting people to have Vulkan 1.3 kind of makes it so that unfortunately mobile is a bit of a no-go, because with Vulkan 1.3 you're kind of stuck with basically only newer phones, whereas like if you wanted to support, you know, a lot of phones that people have and still be able to render the same thing, you would probably need to be like with Vulkan 1.1 maybe is the newest you could go, but I would expect 1.0 to be, you know, as low as it gets, which is kind of like render pass. You'd be stuck in render passness. Yeah, even your GTX 750 Ti supports Vulkan 1.3. Yeah, it's you should look it up. It's there's like a graph I've seen where it's like mobile support for Vulkan is spotty. Let's put it that way. And that limits what you can do. You know, I could jump ahead and say my game requires ray tracing and like, but you know, that's like, I think it's, I don't really have any need at the moment. No, I meant not really spotty. 1.1 has great support. I meant you'll find that some mobile phones support 1.0, a big load of phones support 1.1, a big load of phones only support 1.2, and then a big load of phones 1.3, and then that's what I mean. Like, so if I say it's on the App Store or something, there's a good chance that, and I say it's 1.3 only, there's a good chance that people won't be able to run it because of that. So yeah, didn't quite probably say what I wanted there. Right, let's see. I think what I actually need to do is 1. Yeah, Ratchet is right. 1.1 is pretty well supported. But even some, I would be surprised if it's been negative. There are like phones there are like Android 6. When I was playing, I admittedly got mildly into Clash of Clans a while ago, and they cancelled support for Android 6 in late 2025. So yeah, that just puts it into perspective that Android 6 is like, I don't know how old that is, like maybe like 15 years old or something ridiculous. All right. Oh yeah, this is what he was telling me about. Yeah, it's pretty cool so far. Alright, so now I have got just a number in a struct, which is kind of a waste, but whatever. And I want to just reduce this by this. When this happens once, then it just never does that again. And I think we're good. Now I just need to make this buffer like readable and set the value once per. Okay, so we're gonna have to have this like that, I think. And oops, this I don't know how to do this any other way. I literally don't know how to do this any other way. Oops. What I'm talking about here is I don't know how to say to do it outside of per particle set. So we have a active buffer of particles that gets -1. But that also should be set for the max number of particles, which is kind of annoying because that means it's an array now. I was hoping that I could use the fill buffer, but I'm not sure how that's going to work now because it's an array. What I want to be able to say is, when I've initialized this particle set, so for each particle set I need a new buffer. Sorry, I need values to be set in it. So if it's particle set 1, it needs... I could probably just create this. Good luck, thank you. Yeah, I could probably just set this actually. Instead of doing the fill buffer, I don't actually need to do that. Because I could just set it with initial data. And then, yeah, that's it. So in here, we're going to take it to... No. Alright, so I think we're good. Let me guess, I don't have the particle set in here. No, I don't. Oh man, this is tricky. I think I'm just gonna grab a drink real quick, just to give myself a pep, increase in ability. So I'll just be right back. I mean, you'll still be able to hear me because I'm in the kitchen as of right now, on the kitchen table. So yeah. I don't really have anything to say though, so. Yeah, for those who are new, hello YipTag. I am trying to write as little code as possible to get this game to I think wipe my XP. Yeah. Cook a meal for all of us, yeah, sure. I'll be the chef. Chef escape point. Order up. So I'm trying to write as minimum. I'm trying to get away with like writing as small amount of code as possible while still making it like relatively graphically interesting. If that makes sense. If you want to write the code as a little code as possible, use Haskell. Well, syntactual. The syntax isn't what I meant, but you know what I mean. It's What I'm trying to do is I want a Vulkan burger, please. That's it. Alright, that's it, yep. I've actually got burger patties here, so I could technically cook a burger. Yeah, what would that be? I would have to... Yeah, I would have to allocate 3 buffers, and then I could fry that up on the queue and then present it to you. So, what I mean by like writing as little amount of code as possible is I want you guys to get hold of the game at some point in the future. And if I can get away with not doing something, for example, I keep using this example, but this is an example anyway. Most people know what this is. I'm not writing a an entity component system, for example. We'll receive burger from friendly dev. So that's the yeah, exactly. Vulkan Burgers would be a nice game name, or Duck Burgers. That's it. What are you saying, Angelica is a cutie? Angelica's got a bit nuts. Anyway, so yeah, that's what I'm trying to. That's why I haven't spent like if I can get away, for example, with not having super optimized load times, because I don't have many assets to load, then that's good. Then I won't try to optimize load times. Not that I'm saying I won't need that eventually. Yeah. How did we go from space to burger? Yeah, duck burgers. I have no idea. We are off the record. We have gone crazy mode. So anyway, so I'm trying to think of ways to make this game really nice, and I think particles are a way to make this game look nice and play kind of interestingly. But I haven't got there yet. It's just kind of tricky. We did have particles. Actually, can I show you? No. Okay, they're not rendering, sadly. Maybe in the debug build. Before I haven't built anything yet, I don't think. Okay. And take the assets. Oh yeah, we don't have any assets here. That would cause issues. So there we go. We've got like an explosion that can happen, but it needs to happen like. Didn't close the other. But we need to do it like multiple times in multiple places. And with obviously different textures, different colors, and kind of like a different effect for each particle. So I'm trying to make it like explosion is a bit slow to start. Yeah, it's I think I'm not too worried about the effects yet. I need to like list out what I want basically. I mean, I can speed it up. I can speed up the velocity. So that's what I'm trying to do at the moment, and unfortunately I've really complicated it for myself because I'm trying to do it on the CPU, on the GPU, meaning that we need a way to track when there's no longer any particles on being rendered anymore. As you can see in this, if I do this again, right now in this build, the particles are still being like handled and updated, even though they don't exist, right? Like right now, the maths for calculating the position is still happening. It is still drawing. It is still trying to draw particles that have been removed, and I'm trying to get around that by making a system in the sense that we don't do the maths or try to draw things that have been deleted. That is kind of tricky at the moment, so that's why I'm working on this, and we're having like multiple compute shaders at the moment. Did you say his last name was Burger? Yes. His middle name is Cheese. Does he come with fire? Yeah. Yeah, exactly. Not necessarily to draw. I can do that as well. It's more. Oops. Okay. Let's. No, okay, I've lost that build sadly. Or have I? Yeah. Okay. So those particles. Yeah. I think I crashed this GPU. Yes, I did. The GPU is a bit of a mess right now, so let me just check you guys are still around. Streamer health. Yeah, so I just crashed the GPU. Gotta be careful. So it's not that the particles I need to worry about optimization. It's like this maths here. There's going to be loads of them. So this little bit of maths here is happening every single frame for every single particle, even though they've been removed. So I'm trying to come up with a system to remove the to stop this maths from happening after they've all been removed from this the stream itself is frozen. Is it still frozen? Oh yeah, you're right. One sec. Okay, so it is still. Is there a way to? Can I refresh this? Is that going to do anything? Oh, you can still hear us. Oh, okay, interesting. No, that didn't do anything at all. So maybe turning off the display caption alerts. So that should... What's that done? That done anything? Okay, so you shouldn't see anything, but it hasn't updated. Let's... Is there a way to... Let's turn these back on, maybe... And... Right, let me keep trying. So yeah, I crashed the GPU. Is there a way to... I don't know what to do here. Let me Why is the terminal moving? If I close this, I think I just closed the stream, I think. Okay, so let me pause the timer. I've got a timer running telling me how much I've been coding for. So OBS completely died. Is there a way to... like, try again? I mean, I can get rid of this, maybe? No, it's just not doing anything. Sorry, I'm just trying, like, different things out. And... let's see... I can't see this... Alright, so... Okay, so I can't close it. Yeah, if you restart OBS, if adding display capture back. Yeah, I tried that, sadly. It's printing stuff, but nothing is changing. It's... Oh, this? Oh yeah, you're right. That's really strange. I think it might be caught in a loop. I'm just looking at my own stream. That is really strange. Okay. Yeah, unfortunately... why did OBS crash? Streamlabs has been annoying me recently, and that's why I changed to OBS, and all of a sudden we've got this horrible crash. Which has only ever happened twice in Streamlabs, which is... I can't have this crash every single time the GPU just freezes up. Because then I'm gonna have to, like, do something. I'm gonna have to, like, basically stream from another computer or something. Which is gonna take a pain. It's gonna take a lot. I don't have that set up at all. Lovely UI, yeah. Yeah, I think unfortunately... Just bear with me just a moment. I'm going to try a couple of things, and if not, then yeah, we're probably going to have to restart. Yes, thank you for admiring my UI. It's because I wasn't finished, that's why it's crashed. Okay, I am going to try one more thing. I just unplugged my monitor, see if that did anything. Let's see. No. Alright, yes, unfortunately... Oh, petition to... Oh, I forgot about that. Yeah, thank you. Right, I'm just going to have to restart OBS, I guess. That is so disappointing. That doesn't bode well for the future either. Right, where's the restart streaming? So, bear with me. I'll kick off another stream. Sorry about this, fellas. Yeah, that was disappointing. Yeah, so I'll what I'll do is I'll ping the Discord server. If you want to join the Discord server, there's a link. I'll throw it in the I'll throw it in the chat just before I leave. Yo, thank you for joining us. And you can find me in there, and I'll reping people once it's live again. All right. So yeah, I will see you all guys shortly. And and I'll mess around with the settings just to see if I can just before I relaunch. I'll try and make it so it's a bit more stable for this type of situation. So yeah, I will see you guys in a minute.